Go ahead and get started then. It's just after 11 o'clock. All right. Good morning and welcome everybody to this February edition of Trainee Talks. It feels more like a May or June day in Montreal. It's so warm today. But welcome. For those of you who are new to the program or joining us for the first time, Trainee Talks is a monthly webinar series that showcases the research of our CREATE SE4AI graduate students in their area of expertise related to software engineering and AI. My name is Lori Akiyama, and I'm the program coordinator for CREATE SE4AI at Concordia University, and I'll be moderating the webinar today. So today, we've invited two of our CREATE Master's students, Akshat and Sharon, to share their research with us. I'll begin with a brief introduction of both students, and then I'll turn things over to them for their presentations. Akshat Malik is currently pursuing a master's degree at Queen's University under the supervision of Dr. Ahmed Hassan in the SAIL lab and Dr. Bram Adams in the MCIS lab. Akshat's research focuses on enhancing the privacy of machine learning models. He is also an ML Ops intern at National Bank of Canada. And today, Akshat will be presenting his work on empirical evaluations of graph-anonymized metrics for JIT defect prediction. Immediately following Akshat's presentation, we will hear from Sharon Ho. And Sharon is a master's student under the co-supervision of Dr. Tanya Tajmal and Dr. Imad Shihab at Concordia University. Sharon's work centers around the social and ethical implications of synthetic media and generative AI systems. And last summer, Sharon was very fortunate to be able to have spent 8 weeks at the University of Tokyo's Institute for Future Initiatives, conducting research on the social and ethical awareness of computer science students studying in Japan on the impacts of text-to-image AI systems for creative work. Her presentation is the result of her ongoing research in this area and is part of her master's thesis. Each speaker will have 20 minutes to present their talk, and then we will open up the floor to the audience for questions for 10 minutes. I've enabled the Q&A feature this time, so we can use that if you prefer, or you can simply unmute yourself to ask your question. Either way works. And just to let you know that we are recording this seminar and it will be available to view later on our YouTube channel. So with all these housekeeping things out of the way, I'd like to turn things over to Akshat to begin his presentation.
Thank you, Lori. Okay, so I'll share my screen and get started. Hi, hi everyone. I am Akshat Malik and I'll be presenting my topic today. So, what do good AI ML model need the most? They need data, they need more data, they need lots of data. And no single organization alone can contribute or have that much amount of data. So this creates a need for sharing data across organizations. Yet sharing of these data and model is complicated. Organizations could get the data together to have better results. However, they are unable to do so. The reasons primarily being that this could leak sensitive information about the organization. And also even sharing trained models could leak sensitive information through ML inference and model inversion attacks. So the question arises is, can we share data without leaking sensitive information and impacting the performance? So once again, I'm Akshat Malik, and I'm a student at Queen's University in the MCIS and SAIL lab. And my topic today is empirical evaluation of graph-anonymized metrics for just-in-time defect prediction. I've been working with Dr. Bram Adams and Ahmed Hassan for the past year over this. So a lot of terms in there, and I'll break them down one by one. So what is just-in-time defect prediction? It is a class of defect prediction which uses commit metrics to identify buggy commits. So it uses features for commits like number of lines added, number of lines removed, number of files or author experience to find bugs at a commit level. Finding bugs at a commit level helps in faster resolution of bugs and These metrics can also be used in a within project and cross project settings, so that metrics of one project can be used to find defects in another project. However, the biggest problem with these metrics is that you need large amount of data, which makes it unusable for newer and smaller projects. So the question arises is, can we share this data among between projects? Some studies did show that cross-project prediction is as good as within project defect prediction. And this should enable us to find bugs in newer and smaller projects. However, as I stated before, organizations are unwilling to share data with one another. So what are the different ways we could go about privatizing data or models? So AI model has three components, like there's the input data, there is the model itself, and there is the output data. So to provide privacy, you could anonymize the input, you could change the model training values, or you could add noise to the output. For our study, we focus on the first way, which is the anonymization of input data. We focus on this because this would allow you to share data and the models trained on it. And this is flexible. Once you're sharing your data, you could then train any sort of model that you want on this data. Doing model-specific anonymization makes it very specific and limits reusability. And when you add noise to the output, this prevents data reuse, and also the interpretations of the output is now tied to the noise that is added to the output. So in software engineering, there have been three key contributions by Peter et al., which proposed three novel techniques to provide privacy to software analytics data. They proposed Morph, which is an algorithm which modifies data points by like those list of metrics by a certain random amount. There has been Lace, which is a combination of Morph and Cliff. Cliff, they added a new algorithm which prunes instance based on how frequently they occur. And finally, the proposed Lace 2, which was a multi-party system in which only unique data elements from all different contributors are collected. All of these techniques treat data as a table of row and columns and ignore any logical relation between them. So we believe that like changing the number of files should also change the number of lines added and lines removed, and this is missed in these. However, they're very easy to apply. They provide very high privacy scores, 89 to 99%. However, the performance decrease with them is very significant. It is AUC decreases by 21% and G-mean by 70%. And the anonymized data loses a lot of dependency between the different features. So we believe there must be a better way to provide privacy while preserving performance of these models. So the first question we ask ourselves is it possible to retain the relation between different features during privatization? For this, the first thing we did was reimagine this list of metrics and tabular data as a graph. So all the metrics, all the commit metrics that were there, we represented as a graph of interconnected entities of author, commit, and files, from which we can then derive the the metrics needed for the just-in-time defect prediction model. So the next question is, can we change these entities in a way that provides them with privacy, but also not randomly change values? They change under certain precondition and rules, but also retain performance while doing this. The answer to that is yes. Graph anonymization is a great way to do this. Graph anonymization techniques retain logical connection between entities. They provide privacy to individual nodes and have a minimal impact on performance. So how would graph anonymization work and what would it do? So we have this original graph for which we have these list of metrics. We apply graph anonymization on it, which changes the graph by certain random amounts. If you see the commit, the files that a commit is changing has changed. And when we derive metrics from it, all the metrics that are dependent do change. So our initial assumption that if the number of files changed, should also change the number of lines is observed. Earlier, the commit 9C was changing 3 files and added 30 lines, which now converts to 2 files and 20 lines. And this sort of relation is not limited to these features. There are a list of other metrics as well, and this affects all of those metrics. So with this in mind, what sort of research questions do we want to ask and sort of try to answer? Is how much privacy is gained by these graph anonymization techniques? The second one is what is the impact on performance as graph anonymization is applied that changes the graph? What is the loss in performance? And we also want to compare to the state of the art techniques, which I mentioned before, to see how graph anonymization techniques fare with them. These two RQs are for within project prediction capability. We also apply the same to cross project prediction capabilities, with RQ4 and RQ5 being in cross project setting. We apply our study to these following datasets. The OpenStack and QT datasets are very popularly used in other studies, and however, they're very imbalanced. So we also included another dataset by the Apache projects, which are newer and balanced. And sort of having these two datasets provide us that the general applicability of our work as well. So what are graph anonymization techniques? And so graph anonymization techniques generally change the structure of the graph under certain conditions. In the study, we focus on 4 techniques. One is random add delete, which randomly removes links from one node and adds it to the another. We test between configuration values of 2 to 100. And there is random switch, which randomly swaps 2 links between 2 nodes. So you pick 2 nodes, you swap all of their links with one another. Again, we tried from 2 to 100 configuration value. Then there is KDA, which is K degree anonymity, which ensures that there are at least K elements with the same degree. So if a commit node is connected to 5 files, there should be at least 5 such nodes or K such nodes. And we try values to 24. And for generalization, this is based on the structure of the graph itself. So this doesn't only check the file node, but also check the authors and how many commits they have modified. And we try to ensure that there are at least M nodes which follow the similar structure. And we try configuration values 10 to 100. So how do we measure privacy? Like I've talked about it before, and privacy refers to how much information can be disclosed about the members of the data that are contained in the data. So you could derive relations like there are commits which are modifying 1,000 files. We don't want such questions to be answered by the data. But measuring privacy is very hard. There are many metrics available which check different type of leaks. However, we went with one metric which is called increased privacy ratio, which has been used in other studies as well. It examines, it measures the ability of the attacker to extract information from the data about the sensitive attributes. And it compares what is the change of information between the anonymized version and the non-anonymized version to get how the sensitive attributes have changed. For our study, we use the number of lines added feature as the sensitive attribute. And to calculate privacy, we perform graph anonymization and we measure the privacy gained. We define privacy in 2 levels, between 65 to 80 and 80 to 100. And anything above 65% is considered secure enough to share. And that's why anything below 65, we don't discuss much about it. So how do we measure just-in-time defect prediction models performance? We used 4 metrics. One of them is AUC, G-mean, recall, and FPR. AUC and G-mean are good for measuring performance of imbalanced datasets. However, in this presentation, I focus on AUC alone, just for time. So how do we approach this empirical study and go about answering the RQs? We first extract the version control for each of the project. We extract all of the commit, author, and file entities. We sort them chronologically in an 80-20 training dataset, training test dataset. Out of the training dataset, we get an anonymized list of metrics. From those 80% training dataset, we also make a graph out of it, to which we apply graph anonymization techniques to get an anonymized graph. And then we generate metrics out of which are the graph anonymized metrics. We also apply tabular techniques or non-graph techniques, which we mentioned before, on this data, on the unanonymized metrics to get what sort of privacy or change comes from applying these techniques. So for the approach for RQ1, we take the graph anonymized metrics and the unanonymized metrics. We calculate the IPR score to answer how much privacy we have gained. For RQ2, we take the graph-anonymized metrics, which have been anonymized with different techniques for each of the projects and different configuration values. We train a model on it. For training the model, we use random forest with Smotin to balance classes. And we use bootstrapping, where we use 500 training samples and 500 test samples, which is repeated 100 times. And we get the output, which is the performance of the model. We compare this with the unanonymized metrics to then identify what has been the impact on performance. For RQ3, we now just replace it with the metrics which have been anonymized using non-graph techniques or tabular techniques, and then compare it to the performance of the graph-anonymized metrics to understand how they compare to the state of the art. Now, the previous two RQs were for within project performance. Now we are going to cross project, where we select one project as the testing data and remaining projects become the training data. And all of these training projects have been anonymized using graph techniques for one particular configuration value. Collecting all these training projects, we train a model and then evaluate what has been the impact on performance. And for RQ5, we have a similar approach. Now we just replace it with anonymizing data using non-graph anonymization techniques. And we have a similar setup. And using the results from the previous RQ, we are now able to compare what has been the change in performance. We also compare to manual down, which is an unsupervised learning technique. It only uses the number of lines added feature for classification. What it does is sorts all of the commits based on the number of lines added and considers the top X% as buggy. For our experiments, we used 50% as 50% of the commits as buggy, top 50%. So what were our findings? We saw that all techniques are able to provide privacy level 1 to all projects. So if you look at this graph, which is slightly smaller, but for different configuration values, we see how the privacy score changes. And we see that it is able to provide privacy level 1 to all the projects. And when we further see that all techniques were able to provide privacy level 1 to all the projects that were under this case study. How do random add delete? And we saw that random add delete and random switch were the only one which were able to provide privacy level 2 that is greater than 80%. If you see over here, we see that it goes above privacy level 2. And KDA and generalization were able to provide privacy level 2 for some projects, but not all. It was 3 and 4 respectively. We see that privacy and performance have an inverse relationship, where if you see this graph where you plot the AUC and the privacy measured, it's the solid line is the baseline for that project. We see that with increasing anonymization, the performance keeps falling. So for privacy level 1, the impact on performance is minimal. We see a median decrease of 1.45%, whereas for privacy level 2, we see there's a median decrease of 6.44%. So we also saw that generalization and KDA were able to retain more performance. If we see these graphs, that the performance is more close to the baseline as compared to random add delete and random switch. And they were performing significantly better than these two techniques. We also saw that when compared to morph and lace, the GA techniques perform significantly better. Now, if you look at this graph on the bottom right, we have the morph, lace, and lace 2 techniques. They do provide very high privacy, like upwards of 90%, but the performance impact is very high, decreasing by 21%. When we compared to find that for AUC and Gmean, the GA techniques perform better in at least 83% of the cases, except random switch, which performs slightly worse. And one of the key wins for graph anonymization techniques is the ability to control trade-off. So you could go for privacy level 1 with better performance, or privacy level 2 with slightly lesser performance, but still performing better than morph or lace. So that it provides the user the ability to fine-tune their model performance. Now, when compared to manual down, which is the unsupervised technique, we see that we perform similar or better. Like for lace, we were always performing better. We see that for AUC, in 50% of the cases, it's similar. and in 2 cases it's better. For G-mean, we see that we perform better in most of the cases. However, the biggest drawback with using MD models is that they limit the usability of the metrics, that now a model which has been only trained on line added and only uses that cannot be used in any other context. Now, when compared to in a cross-project setting, we see, first of all, that graph techniques have a very consistent performance, that they stay around the baseline. The red dotted line is the cross-project performance, and the green dotted line is the within project performance. So they stay mostly around baseline. We again saw that random add delete and random switch were the only techniques able to provide privacy level 2 to all the training projects. And mostly the performance of these techniques was similar to one another. KDA did perform marginally better in some cases, but overall the performance was similar across the board. Now, when these techniques are compared to morph and lace, we see that the graph techniques have higher median AUC. They also have more consistent performance, again, except random switch, which has slightly longer tail. Like for morph, lace, and lace 2, we see that they have widely varying and inconsistent performance across different configuration values that we tried for them. Now, when compared to manual down model in a cross-project setting, we see similar results with the notable exception that generalization in KDA now actually perform better in more cases. For Gmean, we see similar results where they are still, like graph techniques are still performing better. So in conclusion, we see that graph anonymization techniques are an effective way to provide privacy. All projects are able to gain privacy level 1 or 2 with at least one technique. The graph techniques perform significantly better than non-graph techniques in within project and cross-project setting. And they perform similar or better when compared to the manual down technique. And yeah, this work was based on 2 of my papers over the last year. One is towards graph anonymization of software analytics data, which has been recently accepted, and pragmatic evaluation of graph anonymized metrics. I should have submitted yesterday, but got busy with this presentation. So this is about it. Thank you.
Thank you
Any
very
questions?
much, Akshat. Yes, we'll open it up to questions. Congratulations on your paper accepted.
Thank you.
And great talk. Does anyone have any questions for Akshat? Don't be shy.
Maybe I can jump in. I wanted to give time for the students, but maybe I can jump in. Akshat, thanks for the talk. So maybe I'm just wondering in terms of applications for these approaches. I remember like with LACE at the time, I think they were trying to do or trying to preserve privacy mostly around like gender and identity type of data, and I'm not sure like if this changes with your graph-based approach. So I'm wondering about like applications of this. Like, is it do you have any idea where this would apply, and if that differs, then like for example LACE? And by application, I mean, is it like medical? Is it financial kind of applications? Is it other kinds of applications?
So we applied it to software analytics data. Graph techniques have been used in other contexts as well, like for social graphs and in other areas. However, this is our first attempt to apply it to software analytics data, and we chose just-in-time defect prediction metrics as our case study. So I believe it could be applied in other scenarios as well, but and if I'm correct, LACE also focused on like analytics data and maybe not on like gender and other areas, but more around hiding patterns in data and how can we provide privacy to them, like, prevent sensitive attribute disclosure.
Yeah, and so for me, like I think the just-in-time data was used more as a like a data source for your study, but I don't think this would be like the final application of this approach. So my question was more around like where do you think this approach would work in terms of like final application, the ideal application, not the the data that's available to get the paper out or something like that.
Um, I I do believe defect prediction is one area. Then I think one area which I did study a bit was like medical records do try to hide it. And then I think these two areas I can think of on top of my head as of now.
Okay, all right. Thank you.
Thank you, Imad. Any other questions from any of the students? No, no questions?
Okay, maybe I can ask another one.
Okay.
And I would really like if the students can ask some questions as well. So maybe my question is more around like runtime performance of these approaches. Do you see a significant difference in terms of runtime performance?
Yes. So as I said, like the tabular techniques for LACE, they are slightly easier and quicker to apply. Graph
Mhm.
techniques require some certain amount of setup that first you have to make the graph and then anonymize it and then
Yeah.
generate metrics out of it. So that does add certain pre-steps to it. So that is certainly a win for the tabular techniques that they are a bit quicker in their application.
Okay, and do you have a quantity, like how much? And does it how does it relate to like the data set itself, the characteristics of the data set itself, like how many attributes they have, how many rows they have, things like that?
So we
Or
didn't
if you
measure
don't,
that,
it's
but it's
fine.
more,
I'm just curious. Yeah.
yeah. So I do remember that this was something I did observe. Uh, it, so I know Morph was very quick, though Lace was not, and then Lace 2 was also slower. So, and it also depended on the data size. So, like for OpenStack and Qt, they are bigger data sets, like 25K commits and 15K commits. They did take longer for both the techniques. So, given the feature set was same, so I can't comment on that. Like we use the same features, it's just the size changes for each project. So, but the problem with like one limitation of Graph was that we had to compute all the metrics, whereas they had it all pre-computed for them. So we were anonymizing it was one step, but generating it was the second step, whereas they already had the generated metrics on which they were just applying anonymization. I would say that if we know what value we are trying for Graph, it would not be that big a difference, but at least for exploration, it did take longer because you had to experiment with a bunch of different values and see what works, what doesn't.
Okay. Okay. All right. Thank you.
Yeah.
Okay, last chance for any questions for Akshat. If not, we'll move on to our next speaker. Okay, thank you very much, Akshat. Great presentation. So if you could stop sharing your screen and Sharon, please go ahead whenever you're ready.
Hello, everyone. So today I'll be doing my presentation. As you might know, as Lori has introduced, I am investigating the impacts of text-to-image generative AI on creative professionals. These insights come from my research that I conducted in Japan. So specifically, my project was done under the framework of the MyText JSPS Summer Program Fellowship that I received over the summer. I did 2 months at the University of Tokyo conducting my research that's primarily interview-based, and I was supervised by Dr. Arisa Emma at the university. The presentation I'll be giving today is a variation of the one I'll be presenting at the AAAI 2024 Spring Symposium that's being held at Stanford University at the end of March. This symposium is discussing various aspects of generative AI this year, and specifically I'll be in the track of the impact of Gen AI on social and individual well-being. This research is also the primary component of my master's thesis. So I would like to share with you my findings from my project with you today. So you might be wondering, what is text-to-image generative AI? I know most of us think of generative AI as ChatGPT, as LLMs, but there's also another world of generative AI that is more creative in terms of imagery. There's also other generative AI systems, such as audio generation, and but today I'll be focusing from images, specifically from text prompts. So what is this type of generative AI? It takes natural language for its prompt, and it generates an image matching this prompt. So as you can see here, this is DALL-E, one of the popular, publicly accessible interfaces for text-to-image that's made by OpenAI. So as you can see here, you would enter a text prompt and it would usually generate 4 images that correspond to what you have asked for. And what is this kind of technology behind it? Well, today I won't be talking much about the technology, but just as an overview, most of these models are based on diffusion models, which are actually based on concepts in physics. So at a very high level, what does it do? It starts with, after all the training, how it's generated, it starts with pure visual static. And the model recalls images and concepts related to the words in the prompt during its training, and that it learned during its training. And it would gradually subtract the static over many iterations during the generation process. So you can see here, after many steps and iterations, it has, generated the image that has matched the prompt. So this is kind of just an example of what this kind of static, going from static to image, looks like. So why am I interested in the non-technical aspects of this AI? So the reason is, text-to-image AI outputs, as many of us have, seen, has reached the quality of human-made art and photographs. So as you can see here, both of these were generated by Midjourney, which is a very popular and very highly renowned text-to-image tool that's implemented as a Discord bot. And as you can see here, these were the prompts that were given to these systems. And it's capable of making very illustrative works as well as very photorealistic works. And a lot of people are rightfully, I think, concerned about what this means on a social level. So many are, motivated to maybe thinking about regulating or, being more mindful of what this means on a social and ethical aspect. For example, a lot of the data that's used for training is unethically sourced. Of course, it's legal for the most part, that data mining and training is legal, but at the same time, many of these works were not, that were used are not consensually obtained. So a lot of people are finding their works in these data sets that they never knew was inside. As well as there's concerns about the privacy and dignity of living artists. So like I said, it comes a lot from the data. The data, there's this notion of maybe this lack of privacy that comes with just scraping data from the internet, and the job loss potential of, what does this mean for working artists and creative professionals in the industry if AI can potentially replace aspects of their work. So to illustrate kind of my point about the data sets, one of the most popular data sets that's used and has been disclosed specifically for Stable Diffusion, which is an open sourced implementation of text-to-image AI, is this Lion 5B data set. That contains 5.85 billion clip-filtered image text pairs. Many text-to-image tools have been trained on a subset of this data set. And many have, of course, billions of pictures is hard to filter through every single one of them, but there are instances where this data sets contain sensitive, private, violent, and not suitable for work imagery. For example, in this image that I have here, someone found that their face was in the data set, and this their face was photographed for a doctor that and they only consented it for their doctor, and not somehow it ended up on the internet without their knowledge, and it was, you know, obviously used in training for these AI data sets without their consent. And you know, what happens, you know, their doctor died in 2018, so who's responsible for this? You know, opting in and out of these data sets is extremely difficult. And what does it mean, you know, when all of these models have trained from these images? Even if you opt out of future data sets, this doesn't mean that previous models can unlearn from this data. So I would kind of see this as a legal but unethical breach of privacy. You know, also, like I was saying, Stable Diffusion is open source. So some of these models are customizable and can be fine-tuned by individuals. So there's also been artists who have found that they've been fine-tuned, having models fine-tuned to the art style. Specifically here, I'm showing you artist Holly Mengert, who is a popular illustrator who has done many works for Disney. And someone on the internet had used her artwork and specifically made a, you know, Stable Diffusion fine-tuned model of her art, and without her permission and consent. And when she found out about this, I'd like to read her quote, because it kind of, I think it's best to kind of have her speak for how that she felt when she found out about this. Is that in quote with an interview with a reporter, she says, "I kind of feel like when they created this tool, they were thinking of me more of a brand or something rather than a person who worked on their art and tried to hone things. And that certain things that I illustrate are a reflection of my life and experiences that I've had. Because I don't think if a person was thinking about it that much that they would have done it. I think it's much easier to just convince yourself that you're just training it to be like an art style, but there's like a person behind that art style." And other quotes, which I won't read entirely, but, you know, she feels like it was taking work that she's learned and didn't consent, and people making art that she didn't consent or give permission to. And for her, it feels very weird that, you know, if people make something weird with it, but she's not associated with it by name, and that's, you know, she has some distance, but having her name, having this kind of model specifically kind of advertised as being her art style is very uncomfortable and invasive. And ultimately, you know, what's the matter with pretty pictures, you know, just using AI for that? Well, specifically in art, she feels that in AI, they can mimic brush styles and textures, but that's not really what makes you an artist. It's ultimately, art is to create lovable and relatable characters, and a lot of times AI, she finds, is struggling with that. So once again, why Japan? So of course, this is a universal topic. You know, it's not just one country that's dealing with potentially the ramifications of this kind of technology. It's on a global scale, but why am I interested in Japan? So Japan has shown an early adoption for industry use of these tools of image generating AI, specifically in Japanese comics and animation. And there have been organizations created to discuss what kind of safe usages can be done with these AI tools. So in June of last year, there's been a consortium that discusses specifically what is safe use and what kind of framework should be developed for using these AI tools. And specifically, I'm interested in the fact that, you know, policymaking in Japan involves a lot of expert knowledge to guide policymakers on understanding the situations and also developing policies for that. So so maybe when I'm explaining about industry use, what kind of examples are out there in Japan? So specifically, Netflix had created a short film in association with animation studios, and the backgrounds were generated by AI. And in this industry, in the animation industry in Japan, there's a huge labor shortage. And that's why they were motivated to generate backgrounds using a variation of Stable Diffusion. And but many criticized it as insensitive. Those who really understood the industry knew that why is there this labor shortage? It's because the industry has a culture of severely underpaying freelance animators who would usually do backgrounds, who would do in-between animations. So it's not that, you know, there's not enough people, it's that a lot of people are quitting because they're not making you know, a living wage with these kind of things. And, you know, just outsourcing it to AI means that, you know, it's not solving the issue. You're just using AI to avoid paying people. And, you know, another industry use. So this non-artist created a comic that within 6 weeks compared to the usual 1 year. And all of the images were used with Midjourney. A lot of people, similarly to this offer, believe that, you know, this kind of tools also allow people without artistic talent to break into industries. So specifically for my project, my research questions were, what do prospective AI researchers see as social and ethical issues with these models for creative purposes? Like I said earlier, a lot of experts are involved with policymaking. I've kind of discussed, you know, shortly, like the social and ethical implications of these tools. So if we were to regulate these tools in the future, of course, many experts would have to be involved with informing policymakers of what that means, how the technology works, and what are the implications. So I'm interested to know what these prospective AI researchers, in this case, computer science graduate students, see as social and ethical implications. And then conversely, seeing what people understand, what kind of social and ethical issues actually arise from using it. So kind of comparing this kind of perspective from future expert knowledge holders versus people who are actually very much informed with the social, legal, and cultural aspects of these technologies and how it would impact creative professionals in the field. So my research method, I did interview studies. So I collected my data in the summer of last year from 9 students, as well as 3 experts. It involved me doing a manual analysis of almost over 20 hours of English audio. And the way that I'm analyzing this data is an inductive thematic approach, where I'm analyzing for major themes and sub-themes that occur during the interview. So I would go from qualitative data, which is the interview data. I'd code, you know, aspects of the interview. So what things have the students said, have the experts said, and then comparing them to each other to derive themes. So like I said, I interviewed 9 students and also 3 experts, 1 lawyer, 2 representatives from an association of freelance artists and entertainment workers in Japan, as well as a professor who's specializes in Japanese media industry studies. So what are my findings? So from the student interviews, this is at a very high level. Of course, everyone had various, you know, opinions and experiences with text-to-image and how they see as social and ethical impacts. But on a broad view, many associated the output quality to the social and artistic value. So what do I mean by that? You know, having high fidelity generations is good. Because, you know, it generates good images, so it has a high value. It's useful. And, you know, what about the data? Well, publicly available data, it kind of to them feels like how a human learns from data. And that's kind of the pros for using copyrighted data. And a lot of it is necessary. As Akshat said, you need a lot of data for AI models. So of course, having billions of images is necessary for these tools to work in the first place. However, some of the limitations come from, using the tools as is. There's limited control on the final outputs. Like I showed you earlier with DALL-E, you're only able to input a text prompt and images are already generated from that. So there's very little fine tuning in that respect on how these models kind of interpret the words and generate the images. And kind of the ethical issues and limitations also come from this training data. There might be harmful stereotypes that are portrayed within many of these images, also illegal content and copyrighted material. And at the same time, these training data also represent an upper bound. So what does that mean? These models are as creative as the human made input and the data that is in these models, right? So it can't go any further because that's what it's learned from, is from the data that it has. So that's what some of the students has said. So the positive aspects is, like I said earlier, with one of the comics that was published, non-artists can create illustrations, and maybe these tools can increase the productivity for artists, so that it allows them to have assistive capabilities and a maybe lowered barrier of entry to become, not maybe become an artist, but to create artistic works. And they saw it mostly as a positive impact for society or industry in the long term. However, some of the negative things that they brought forward was that copying an artist's style or using their art without consent is kind of very problematic if used specifically for those reasons. And they might be opposed to the technology if they were artists and not researchers. So that was one of the things I found really interesting, was that many of the students that I interviewed were quite positive or optimistic about the use. But when I asked them, how would you feel if you were an artist yourself? And they said, maybe I would have a different opinion if, the nature of my career was affected if I was an artist. And, I'm a AI researcher, so of course I'm interested to see how these tools are developed and how, amazing they've become. And so, they've kind of demonstrated this openness to regulations and ethical guidelines because, as I said earlier, many of them acknowledge that there are potentially negative aspects to this technology, and that maybe having guidelines or regulations could help kind of mitigate these concerns. So from an expert point of view, the lawyer that I interviewed shared that, there's no restrictions on AI data mining and learning in Japan, and that copyright infringement usually applies to the generation and usage of the tools. So what areas of improvement could be done is, disclosing this AI training data in advance, so that if there's a suspected copyright infringement, that those that are that have been infringed upon can see, is this actually in the training data, and making the process easier to prove damages from infringement. On the social implications, when I was interviewing the two representatives from Arts Workers Japan, they really felt that these kind of tools felt like stealing from a honed craftsmanship that they've developed over the years, and that, it might take away human-centric and fulfilling work from them. So I thought one thing that was quite interesting was when they said, we're not really opposed to AI if AI is done to kind of take away mundane, very bothersome tasks. But as you can tell, these text-to-image tools can immediately just, do all the generation itself. And a lot of these artists are artists because they enjoy making art. So if these tools can take away fulfilling work, what does it mean for them? And, there's also a lack of resources and understanding of the situation for them. And in general, they felt that there was a lack of consideration for those working in the industry. Interestingly, of course, I was saying there's a lot of industry use that's being done with these tools. And what does this mean for these creative industries in Japan. So it could mean that a lot of existing practices are going to outsource to AI instead of humans. A lot of times in animations and in comics, there's assistants who work on it. It's not just one person doing everything. A lot of the times, even in comics, even if there's just one name that's just the creator or the main artist, there's actually a lot of people working behind and supporting this person. And a lot of this assistant work could, be outsourced to AI. And this work already is uncredited, underpaid, and under-acknowledged. So it could significantly impact these workers. And these workers usually are aiming to become, craftsmen themselves, become, full-fledged published artists. And, outsourcing this assistant work might deprive them of having this work. And this work is ultimately, for the most part, kind of this mentorship for them. A lot of these artists go through this mentorship process, and this might mean there's a reduced training that's necessary for honing a craft and a lack of preparedness for an artisan role. And of course, artists, for the most part, lack the time or resources for litigation when a lot of them are struggling to make a living wage. So overall, the general implications from my study is that from how I was interviewing the students and also the experts, I noticed there was this gap of this understanding of how text-to-image kind of affects creative work. For the most part, students talked about, improving efficiency, lowering the barrier of access to generate artworks. But I saw this gap of, a lot of the students talked about doing creative work as if one person is doing everything themselves as an artist. And a lot of times in creative industries, that's not the case. There are big studios with many workers. And so this significant oversight from the students is viewing creative work as independent artists rather than a symbiotic network of workers. And using AI might jeopardize this workplace pedagogy that exists and replace fulfilling and meaningful tasks in their job. And then also, seeing just data as data, when a lot of times this data comes from people, is kind of not ignoring, but under acknowledging, not seeing that there is kind of this infringement of privacy and dignity when you only see artworks as just data for an AI model. Because ultimately there are people who supplied these data, and for the most part without their consent. So what opportunities come from my research? As I said, I discussed mostly about Japan because it was an interesting use case or a case study. But other countries could learn from this. Every country has creative workers, has creative industries that can see parallels with my findings. And it could also highlight gaps in computer science higher education. As you can see, a lot of the students, I said, they kind of just understood this creative work as independent creative work. So there probably needs to be more awareness of the social aspects and impacts of Gen AI tools in higher education for when training these computer science students who may become experts who may inform policy making. And then as such, there is the motivation to maybe develop formal and recommended ethical guidelines for AI-oriented research, especially for generative AI and text-to-image generative AI. So yes, that's a brief overview of my research. So thank you very much for listening. If you have any questions, I'd be happy to take them.
Thank you very much, Sharon. That was amazing. Does anyone have any questions for Sharon?
Yes.
Hi.
Yes. Oh,
sorry.
Go ahead. I can't see who you are.
Yeah. Okay. I have a question, but
Okay.
I saw others raise their hands, so maybe they can.
Okay. Yes, go ahead, please.
Oh, okay. Me? Okay.
I think I think Jasmine maybe had her hand up first, and then Shani, if you want, you can just put up your virtual hand. But maybe we'll go Jasmine, Dr. Adams, and then Shanu.
Okay, sounds good. Sorry, I missed the hands.
No problem.
Okay, thank you. Thank you, Sharon, for your talk. It was really interesting. I have maybe it's a big question that maybe you can't answer, but I'm taking a chance. So you talked about a lot of like breach of privacy and things like that. I'm just curious to know how one can evaluate this in cases of closed source model where we don't necessarily have access to like the training data, so we can only make assumptions maybe on the outputs that we see. And I guess the case is the same for even open source models. Not all open source models make their training data publicly available. And I can even extend my question to maybe how does this apply to maybe individuals? Like we discussed the other day about Midjourney, right? That we can fine tune Midjourney with some whatever data that you have. So how does this concept also extend to personal use of AI? And when does it become like a breach of privacy? Let's say if you keep this output for yourself, or if you share it, or if you publish it, like maybe just like clarification on this. I'm just curious. Thank you.
Yeah. I mean, those are quite loaded questions that I think a lot of people are still thinking about. When it comes to, like you said, some tools have been outwardly public about their training data. So for example, Stable Diffusion, and that's why a lot of people have been, very critical about it, have really put like a magnifying glass to kind of see what kind of problems come from it, because the training data is like public, so we can kind of see what's really inside. Like you said, for example, like Midjourney or DALL-E from OpenAI, they haven't made the training data publicly available, so you can only, like you said, you can only guess. But at the same time, a lot of the things from these models, if they're outputting, let's say you're putting in a specific celebrity's name, right, or a specific term or subject, and these models can generate it. For example, if they can generate, I don't know, a Pokemon, or if they can generate a politician, that means that these images were in the training data, right? These figures or these people were in there. So of course you can only make assumptions, but at the same time, I think it's been pretty much kind of been discussed anyways, that they are taking images from the internet, because how can you have billions of images like of your own, right? I think that's like a lot of these tools have to have scraped from the internet, and there was no way to consent from all billions of offers from these pictures. So like I said, it's really difficult to answer the question, but I think it's more, like I said, it's obviously it's legal. If not, these tools wouldn't have existed in the first place. But it's kind of this kind of moral dilemma of, do I want to use something that potentially, is making people uncomfortable having had their data used for it? So yeah, I don't know if that answers your question.
Thank you.
Yeah, so a great presentation, great work. So I'm wondering, is there like some inspiration that can be used in this domain from like other related artistic domains, for instance, like music production, and so on? Because like for example, like sampling of other people's music is something that's been an ongoing issue, but also an ongoing practice for a couple of dozen years, like somewhere in the 80s, I guess this started. So people can really take somebody else's music and mangle it in all kinds of ways. You cannot even at first hear anymore the original one, but still some people figure it out, they attribute it, and it's even an honor in some cases to be sampled by somebody. So I'm wondering, like, is there any things like that is also being inspiring to, for example, in this field?
Yeah, so of course, I'd say the general people who are kind of really for this kind of technology are kind of seeing it as kind of, this kind of technology can be viewed as kind of, like you said, not really remixing, because I think some people are really don't feel that this technology is necessarily remixing works, but that it's kind of a derivative works, right? So they're deriving from concepts in the data and, you know, making outputs from there. I think it's hard for me to kind of answer your question, whether or not, you know, is it kind of similar to sampling or not? I would say no, because sampling really takes specific, you know, whole aspects of these, you know, audio clips and remixing it. And even then, you know, there's a significant reworking of these kind of clips, right? You know, there's a lot of human involved, and like maybe we recently had a talk as well about, you know, what does it mean intellectual property and copyright. And right now the understanding is that, you know, AI works can't really be copyrighted by an individual because there's not enough significant human input in it to be claimed that it was copyrightable, because copyright is mostly attributed to human-made works. So yeah, so at the same time, I think it's quite difficult to answer this question. It's still a lot of a gray zone. But I'd say because there's a lot of lack of human control over how the things are generated, or the process in which elements are taken from the generation, especially for generations that are only from text prompts, that right now I think it's probably not comparable.
Cool, thank you.
Okay, I think we'll take one more question from Shen-Yu, and then we'll have to wrap things up.
Yes, thank you. Very good presentation. So I have a question about the impact on industry in different areas. So you have mentioned that the impact of AI using on in like animations and comics. So is there any difference? Also, for example, for design and also like for illustration, because like for comics and animation, the workload is like a large, but the work itself is simpler compared to illustration. So is there any difference on the impact of AI using like in these industries?
Mm-hmm.
So yeah, this is my question. Thank you.
Yeah. So if I understand correctly, you're asking whether, because, you know, comics and animation involves a lot of workers, for illustrations, it's usually just one, the majority of the time, just one person creating an illustration. So how does that impact, right?
Yeah. Especially like for animation, the work is simpler, relatively simpler compared to illustration. So yeah. So I imagine that make a very good illustration is harder like than using AI than make like a animation like using AI. Yeah. Like a single image.
So you're saying that animation is easier with AI, or the other way around?
Because like the image of animation for one single image is simpler compared to illustration, but like it requires a lot of workload to make a lot of like images and make them together. So, but for illustration, for one image, like it's more complicated than animation, like for single image. So is there any difference on the? So what is the impact of AI using in this area? What is difference? Because they have different like the practice is different in like this different industries. So yeah.
Okay. I would actually say that illustrative work, for the most part, with this AI is actually easier to automate, because, like I said, you only put in text prompt and it outputs an image. However, you know, how well that image corresponds to what you want is also very difficult to control. So there's that, you know, constantly putting in more prompts to fine tune kind of the output. That takes a lot of time to kind of eventually generate something that you kind of want. So leaving it kind of up in the air for the AI tool is kind of difficult in that sense for one illustration. For animation, it's difficult because you might be able to generate individual frames one by one, but at the same time, this flow and these kind of compositions is really difficult without one person kind of without this kind of human input. So actually, I would say it's quite difficult for animation to kind of achieve that. The goal is to use these kind of AI tools to do in-between animations. So between keyframes, there needs to be a lot of frames to move from one major action to another. So there's maybe this automation of going from one to the other, this kind of transition, but it's still in the works. It's not perfect yet, these kind of tools. But in terms of illustration, what kind of impact it will have? Well, like I said, it can do the full generation on its own. So, some companies might want to just completely use this tool and not hire an illustrator for it. And it's easier because, you can just type away at these AI tools and eventually find something that's kind of fits your idea of what you want. And some people will take that chance to, cut costs and not want to hire someone who has that experience, because ultimately it might actually take less time to just create something that's kind of similar to what you want. So that's kind of the impact, is that, some people who are doing illustrations, especially, freelance artists, might find that, some people will choose not to commission them and will just use AI tools. I don't know if that answers your question.
Yeah, okay, thank you very much. Yeah.
Okay, thank you, Sharon. We've already gone over time, but I see, Anirban, you have a question. Can you ask it very quickly, and I'll allow you to.
Oh, yeah. So yeah, I will keep it short. Anyway, excellent presentation. So I just had a question. So under legal implications, you have mentioned like there is no restrictions on AI data mining, and an area of improvement could be like, disclosing the public data set. But my question is like, since the data is already out in public, right? It's internet and anyone can get it. So do you think some restrictions need to be put on data mining? Do we need regulations? Because like if it's on the internet, it's like public data, right? Anyone can grab that. So if someone is writing a script to like curate a data set, do we need to put restrictions on that? I mean, do the people you've interviewed, do they feel that there should be restrictions on that?
Yeah, so I think for the most part, most people would say yes. I think for the most part, my impression is that a lot of these regulations about AI training and data mining came in an age where AI was mostly doing decision making, like processes, learning from data to just do evaluations, right? Like statistical evaluations. But now with generative AI, these AI tools are capable of generating. And that's an aspect, I would say, when, these laws were kind of made, that we didn't really imagine that AI would start generating things that are very human-like. So I would say that's one of the reasons I think that, this kind of data mining and learning is kind of free for all in the first place, was because we didn't really anticipate these kind of AIs to be able to do such a thing. At the same time, from the people I interviewed, especially for the workers, of course, they think that at least there should be consent done. Like if you're going to take the data from someone, you should allow this kind of consent to be given, especially because images are very sensitive material, especially if it's, with real people inside. There's also been cases where these tools, although a very small probability, can generate, can replicate data from the data that it learned on. So can replicate the data in its data sets. So completely saying that, these AI tools are completely original is not necessarily true, although for the most part, it won't replicate something exactly in this data training set, but there is still that probability that it will do that. So there is kind of this breach of privacy in that case, especially if it involves real people. And I think it's just really this matter of, data privacy aspect to it. So at the same time, I think a lot of people who do have, their faces or their work in would like to see some way to opt in and opt out of future data sets that are being used to train these models, having regulations on kind of what kind of data can be used when training generative AI tools. So yeah, at this point, I can't really say if I'm not, part of the, I'm not a lawyer or, someone who works in the justice system, but really, I think a lot of people want to see, people being able to control what kind of data goes into AI.
Yeah, thank you.
All right. Thank you so much, everybody. Sharon, that was a fascinating topic, and I think we could go on and on. There's so many implications on these generative AI technologies on the creative industries. So maybe we can continue the conversation. But thank you very much, everybody. Thank you to Akshat and Sharon for being our presenters today. Please join us for the next edition of Trainee Talks. It'll be on March 25th. Have a nice day, everybody.
Thanks, everyone. Bye-bye.